For this example, we want to solve the equation 4 sine squared x minus 3 equals 0, where we define x as being from 0 to 2 pi, just in different symbols. But for this, it's the same sort of idea we always have in terms of isolation and solving. It's just that, well, we have to be a little bit more careful with how we end up where we want to be. So, we have our 4 sine squared of x minus 3 equals 0. We want to get the trig stuff on its own as best we can. So we're going to add the 3 over. 4 sine squared of x is now equal to 3. Well, we've still got a constant multiple. Let's get rid of that. Divide the 4 over. Sine squared of x equals 3/4. Well, we're getting closer. Let's take the square root, and what we'll have from there is that sine of x is equal to the positive or negative, because we're not entirely sure just yet, root of 3/4, or if you prefer, and most would, plus or minus root 3 over 2. Which again is one of those common types of things. It's a common value for the sine function, where since we're looking from 0 to 2 pi, we don't care about the negative in terms of the angle, but we do have to be mindful of the fact that we can get negative root 3 over 2. So we're going to get all of the options coming all the way around the unit circle here. That is, our possibilities for x can come from either positive root 3 over 2, which would occur in the first and second quadrant at pi over 3 and 2 pi over 3, as well as the values where root 3 over 2 is negative, which will happen on quadrants 3 and 4. That is, at the angles 4 pi over 3 and 5 pi over 3. But in the restricted domain, these are our 4 possibilities. And for our next example, we're going to look at having to do something like this where it takes a little bit more movement with our trig functions. We're going to have to look at how we can factor to solve.